In this video, we're going to look at both the mass percent and percent composition of chemical compounds. To start with, we're just going to go over the law of definite proportions. So this says that elements in a compound are always present in the same proportions by mass. What that means is, for example, water is always going to be 2 parts hydrogen and 1 part oxygen because there are 2 atoms of hydrogen for every 1 atom of oxygen. And we know that each of these has a molar mass associated with them, meaning that they're going to be with the same proportions by mass as well. To start with then, the mass percent is the mass of an element in a compound expressed as a percent of the total molar mass of the compound, and that is what is defined as the element's mass percent. Let's look at an example then. First, we're going to find the mass percent of hydrogen in water. Now, to find a mass percent, the first step you want to do is find the molar mass of water. Remember, to find a molar mass of a compound, we have to add up the molar mass of each of the individual atoms. So we have 2 atoms of hydrogen plus 1 atom of oxygen. So that's going to be 2 times 1.01 plus 16.00, giving us a molar mass of 18.02 grams per mole. Don't forget your units. The second step then is we want to divide the mass of all of the hydrogen elements in our compound by the total molar mass of our compound, or of water. And we're going to multiply this by 100 to get a percentage. So we're going to set this up as percent hydrogen is equal to, we need to do 2 times the molar mass of hydrogen, because there are 2 atoms of hydrogen in our compound. And we're going to divide that by the total molar mass of water, which is 18.02 grams per mole. And then multiply that by 100. When we do that calculation, we get 11.2%. You should have 3 sig digs in your answer because 1.01 has 3 sig digs, whereas 18.02 has 4 sig digs. And remember, multiplying or dividing always goes by the lowest number of sig digs. A percent composition just takes the mass percent one step further and refers to the relative mass of each element in the compound. Let's take a look at another example. In this example, we want to find the percent composition of H2SO4. Again, what we're going to do is find the molar mass of our compound, H2SO4. So we would take 2 times the molar mass of hydrogen plus the molar mass of sulfur plus 4 times the molar mass of oxygen. So when we do that calculation, you get 98.09 grams per mole. In the second step, what we want to do is find the mass percent of each element in this compound. So we're going to set it up exactly the same way as the last example. Our percentage of hydrogen, again we have 2 hydrogens, so it's 2 times 1.01 over 98.09 times 100. If we do that one, you get 2.06%. Okay. 3 sig digs because the 1.01 is 3 sig digs. Let's do percent sulfur, so that's going to be 32.07 since there's only one of them, divided by 98.09 times 100 is going to give us 32.69%. This one's 4 sig digs because our molar mass of sulfur is 4 sig digs. And finally, the 1% of oxygen is going to be 4 times 16.00 divided by 98.09 times 100, which gives us 65.25%. Again, this one's 4 sig digs because our molar mass of our oxygen is also 4 sig digs. So sometimes you might see 3 sig digs with your answer, sometimes you might see 4, depending on the molar mass of the atom that you have in your calculation. A really nice check here to make sure you've done the problem correctly is take all 3 or however many percentages you have, add them all up. They should add up to 100%. If they don't, go back and double check your work because you probably made a mistake somewhere.